Okay, kids, today we're going to get into section 2.5 Scatterplotts. This is your well-rounded math teacher, Mr. Picard. This is one of the more bigger ideas in algebra that we're going to be covering. One of the reasons we learn algebra is so we can make predictions on data. And that's kind of the new wave in businesses nowadays. We can find patterns and relationships in data, generalize these patterns, and use the data to make predictions of future events. That's basically what we're going to be using algebra for. We're going to use our prior knowledge of slope and linear equations to write prediction equations to accurately predict the future of different outcomes. So we have a set of data here. We're comparing years to lives in thousands. All states in the districts of Columbia have enacted laws setting 21 as the minimum drinking age. Okay, so this table shows how many lives that are being saved year after year by reducing the drinking age or increasing the drinking age to 21. So what we're going to do is graph this data and then eventually make a prediction and see how many lives will be saved in the year 2015. So first of all, I'm going to graph this data real quick. You can see here it's already set up. Years is on the x-axis. That's my independent variable. Lives saved depends on the year it is, so that's my dependent variable. And I'll start graphing these in here. And there's my data points. It looks like it's pretty much aligned right now. So what we're going to do, plot the information on the graph above or below, and we did that. Draw a line of best fit. Line of best fit is the line that matches the data the best. So we'll go up here, I'll grab a line, and I'll say it looks something like that. Now that line doesn't match the data too well. It's got about the same slope, but it should be something like this. Maybe, and basically every point goes right through the line. So there it is. There's our line of best fit. Describe the correlation. Well, if you look at the line, as it goes to the right, it's going up. This is a positive correlation. In other words, the slope of my line will be positive. Now, write a prediction equation. Well, what we have to do is to pick 2 points on this line and find our slope and find our y-intercept and write our prediction equation. Well, I can pick any one of these points, so I guess I'll just go with the first one, this point right here. It's on the line, and I don't know, we'll go with this one, 2002, 2119, doesn't matter. And it doesn't even have to be a point on the line or from the data. It could be where it crosses the grid. Nice, it doesn't cross very well there, but so I wouldn't use that one. But anywhere where it crosses the grid or a point on the line. So first of all, 1999, 19.1 is 1 point, and 2002, 21.9 is the other point I'm going to use to write my prediction equation. Slope is change in y over change in x. So we're going to have 21.9 minus 19.1 all over 2002 minus 1999, which is going to give me a grand total of 2.8 over 3. That is going to give me a slope of, we'll say rounding it, I'm going to write it as a decimal, 0.93. And what does the slope represent? Well, it's 0.93 over 1. You save about 0.93 times 1,000 lives for every 1 year, because it's lives saved in thousands on top compared to the number of years. So that's what we're working with there. Now, I will use this point right here. So I'm going to say y minus y sub 1 equals m times x minus x sub 1. So y minus 19.1 equals 0.93 times x minus 1999. Okay, so simplifying here, y minus 19.1 equals using the distributive property now, 0.93x minus 0.93 times 1900, 1859.07. Finally, adding 19.1 to both sides. And now be careful with this. This is where a lot of students make mistakes. I almost did myself. You're adding 19, so you're actually taking away from the negative 1,859, and you should end up with negative 1,839.97. Okay, so this right here is our prediction equation. We can use it to make predictions. In fact, the prediction we're going to make right now is this. Use your prediction equation to find the number of lives saved for the year 2015. Well, y is the number of lives saved. X is the year. We decided that earlier, so I'm going to plug that in. I'm going to say y equals 0.93 times 2015 plus, minus 1839.97. Okay, 1,839.97. So, and we solve this. When I multiply 0.93 times 2015, I get y equals 1873.95 minus 1839.97 for a grand total of this 33.98. Now what does that mean? Well, I'd round it to 34. 34 what? 34 lives, 34 times 1,000. They're saving 34,000 lives in that year by raising the drinking age. 221. That's a prediction. You could make a prediction for the year 2030 if you wanted to. Any prediction you wanted to. So that's what we're using Scatterplotts for. We're collecting the data, graphing it, coming up with prediction equations, and then using it to make educated predictions. Scatterplots correlations. Well, this last scatterplot we talked about it being a positive correlation because if your line, and you can see this line here, it matches the data best, and the line itself has a positive slope, so that has a positive correlation. This one over here has a negative correlation. You could say it's something like the age of a car and how much it's worth. When it's brand new right off the lot and it's worth 20,000, every year the price goes down until it levels out. But in this case, negative slope, negative correlation. And then finally, you're going to have plots like this also where you can't make any correlation really. A line that closely approximates a set of data is called the line of best fit. These two right here are what we would call line of best fit. An equation of such a line is called a prediction equation because it can be used to predict outcomes and give input variable. And that's what we did with this last problem. And we're going to try another one now. And this one, this graph is talking about, this table, is the price of a new privately owned one-family home. And years, we have years here, and we have the price. Once again, year is the independent variable, so we're going to put that down here. And the price of the house depends on the year, so we'll put price on the y-axis. Here's my x, independent variable. Y is my dependent variable. Okay, so I went ahead and graphed the data, and I threw my line of best fit. Now, it goes through one point. It goes through this initial point down here in 1994 and 130, and then there's 4 points below it and 1 point above it, and you're probably thinking, maybe I should move it down a little bit. Well, I kind of left it like this because it looks like it's going to start jumping up here at the end a little bit. So I wanted to shade towards that 1 point a little bit above these 4 here. But it best matches the data. I mean, everyone's line of best fit is going to be a little bit different, so it's not a big deal. If your graph is a little bit different than somebody else's, it's all in how you interpret the data. So describe the correlation. I guess I would say this is positive, definitely. And it says find a prediction equation. Well, we got our line of best fit here. Now we got to write a prediction equation for it. Now, the points I'm going to use to come up with it are this one, definitely. 1994 and 130. And I'm going to use this one right here. It's not a piece of the data, but it crosses the grid really nice. At 2004, and it looks like it's at 210. So what I'm saying is, it's just got to be a point on the line. It doesn't have to be one of the data points. It's like this point right here is not a data point, but it's on my line. So starting out with the slope, change in y over change in x. 2010 minus 130 over 2004 minus 1994. It's going to give us 80 over 10, or our slope is nice round number 8. So plugging in our information, y minus y sub 1 equals m times x minus x sub 1 into point slope form. And I think I could use y minus 130 equals 8 times x minus 1994, and then multiply. We get 8x minus 15,822. Adding 130 to both sides. This is negative 15,000. This is positive 130. So really, you're taking the difference. You end up with y equals 8x minus. Oh, I made a mistake here. Let's go back. This number is actually 15,952 plus the 130 is going to give me negative. Here's where we get 15,822. Now my slope is 8. That means it goes up $8,000 for every 1 year, basically, the house. And my y-intercept is negative 15,822. Now, if you look over here, it looks like my y-intercept is going to be a little bit less than 130, but this is at 1994. So this graph doesn't start at 0 and 0. So the y-intercept doesn't really represent this graph very well right here, but it really doesn't matter. We still can use it as a prediction equation. And we want to predict this. What is the median selling price of a similar house in 2008? Well, it's going to be worth y money equals 8 times 2008 minus the 15,822. If you work this out, you should come up with $242. But really, it's per 1,000, so that's $242,000 will be the median selling price in 2008. Okay, you can use your graphing calculator to come up with your prediction equation. Another name for prediction equation, what we've been finding, is linear regression. Don't get the two confused. Generally, if you use a calculator to find an equation of a line, it's called a regression line or linear regression, same thing. And if you find it by hand, it's called a prediction equation. So basically, we're finding the same thing, but I'm going to show you how to use your graphing calculator in order to do this. And we're going to use that same problem we just did and kind of compare answers a little bit. So here it is with the TI, Inspire, CX. And then if you want to use your TI 8483, you can go to YouTube, should be in your packet, and type in linear regression TI 84 and there'll be a bunch of problems. It'll show you how to do it on YouTube, and I'll walk around tomorrow in class and show you how to do it also. But anyway, it's really easy on the TI Nspire CX if you have one of these. First, we're going to hit the on button here, or the home button, and we're going to go to new document, and we don't want to save. So we're going to go down to lists and spreadsheets here. We're going to go up to A here, and we're going to type in, oh, what are we working with? I got to find that again. Okay, I typed in year and price. I'm going to go down now into the A one here and the B column. Those are the titles, and we'll show you those in a minute. And year, you're just going to list in the data. I don't want you typing in anything in this gray box that goes just below year and price. We'll leave that row open. That's for making rules and doing different things. But now I'm just going to enter the data. So okay, so here's our data typed in. Now we want to put it in a scatter plot. So what we're going to do is this. We got to add on another screen here. So you're going to hit Control right there, and then the I button, and that'll add another screen for us here. And we want to go down to Data and Statistics right here. And you can see here's all our points. What we have to do is go over here to where it says click and add a variable. And this is going to be our x-axis, so we're going to hit year right here. Kind of puts it in a little graph there. And you're going to put your hand over here, or not your hand, you're going to scroll over there. You can see me scrolling over. And then we hit price, and there's our graph. Graphs it very nicely for us and quickly. What we're going to do now is come up with our prediction equation. And the way you do that is you hit menu. And we're going to go down to analyze this graph. Then we're going to go down to regression, linear regression, our line of regression. Select it, and then you can see right here the top one, it says show linear equation mx plus b form. Hit that again, and there, right there, see if I can grab it and move it. There's our line. They had for a slope, oh shoot, let me go to that again. Oh, I'll lose it. Oh, I lost it. But it was the slope, and it was the y-intercept. Okay, I got it back here. You can see that this is our slope, 8.67 roughly, and the y-intercept is negative 17,176. It's not the exact same thing that I had, but it's actually pretty close. Let's see if I can pull it back up here. 17,176. The deal is, if you plugged in that same year, you'd probably get pretty close to the same thing. The slope is positive. That's the main thing. You can see the y-intercept is negative. Those are two things I check to make sure are right. And the slope's 8.6. It's really close to what I had. So you can use your graphing calculator to find your prediction equations. They're called linear regressions. And that's it. We'll see you tomorrow. We'll work on this a little bit more.